In this section, we are going to discuss about a particular concept called equated monthly installments, or EMIs as they are commonly known as. Now, what do we mean by EMIs is essentially the fact that if you take a home loan or any kind of loan and you are repaying it over a period of time, that gets classified in the form of equated monthly installments. So there are installments that you have to pay every month, right? So there is a loan that is to be repaid, and when you repay this loan, the repayment happens in the form of what is called as equated monthly installments, and this is also known as EMI. Now typically the way it works is, if you have a loan amount, whatever is the principal amount, when you make a repayment, the repayment is a combination of the interest, and because you have to retire the loan over its tenure, there is a combination of some principal as well, right? So in a sense, the equation that works out is EMI is equals to interest plus principal. Now obviously you will realize that these two components will keep moving because EMI is fixed. This is a single number that you have to pay for the next 15 years, 20 years, 5 years, depending on what the time of the loan is. So interest and principal numbers will keep changing to give you the same addition number, right? Typically, when you pay an EMI, in the initial period, the interest component is high. So in your EMI, let's say the first EMI that you pay will be interest 1 plus principal 1 for the first period. Some amount of the principal will get repaid. Now EMI, let's say 20, just argument's sake, on 20th month, your EMI is going to be equal. These two numbers are equivalent, right? But interest 20 will be lower. Let me rewrite it. So interest 1, principal 1. When you look at something like interest 20, your interest 20 will be lower. So this number is lower because the interest keeps going down. Why? Is because you've paid some part of the principal, and over a period of time the principal 20 will be higher. Why? Is because if interest goes down, the EMI has to remain fixed, right? So that's how you look at calculation of these. So let's try and create what is called as an EMI schedule and try and understand how that works. So let's go down and put in a few terms here. What we are going to do is we're going to put we're going to put the month number because it's an equated monthly installment. Let's look at the question statement. It is Ajay has taken a loan of 40 lakhs and is expected to pay 12% interest on it over 20 years. Calculate the EMIs, equated monthly installments. So 12% interest, 40 lakh principal, this is the principal amount. Tenure is 20 years. Tenure has to be also written in the term of months. 20 years is going to be 20 multiplied by 12, that's 240 months, right? So number of months is given. Now remember, in every period there is going to be a principal repayment. So principal outstanding has to be looked at, correct? And we'll equate this and work this with examples as we go along. Then you have interest repayment, then you have principal repayment, and you have EMI, right? Now let's take an example and let's try and understand how does this work. So what is going to be my monthly interest? If this is my annual interest rate, 12%, my monthly interest is going to be this divided by 12, which in percentage terms would be 1%. So in the first month, my interest repayment should be 40,000 into 1%. Correct? Looks logical? That's the first month interest repayment. Let's assume, for argument's sake, that I also repay a principal of 10,000. Right? Now what happens is, if you think about it, you started with a principal outstanding of 40,000. Now you have an interest repayment of 40,000 and principal repayment of 10,000, which will make the EMI to be 50,000. That's an assumption as yet. At the end of first month or beginning of second month, the principal outstanding is 40,000 minus 10,000. So when you calculate the interest, this time the interest is 1% on the principal, which is 39,900 now, right? 39 lakh 90,000, right? Which means if I have to keep the EMI constant, the principal number has to increase to 10,100 and so on and so forth. Correct? If you compare this to the next month, you will find that your principal outstanding should be 39,900, and then you multiply this with 1, so that's your interest component, and you can copy and paste this below. If the EMI is fixed, then you see principal keeps changing, interest keeps going down as you go along. This is just to show you the example of how it works, and principal keeps going up every month. So much so that in the last month when you make the repayment, the final number is only the principal, right? Now let's try and find out what is going to be this EMI in the month, it's in each month itself, right? For that, we have to understand a function called as PMT. That's the function that is important for us. Let's try and understand the PMT function. So let's understand the concept of PMT. So what I will do is I will delete this component to begin with. We will start with a principal outstanding of 40,000. The EMI is going to be calculated based on a formula called PMT. So let's plug in equal to PMT, and let's do a PMT bracket open, function open, and look at the arguments of PMT. So PMT looks at a rate number. Now in this particular case, the rate has to be the monthly interest rate that we are looking at. It looks at the number of periods. N per means the number of periods. For us, there are 240 months. It looks at what is the present value, and it looks at what is the future value. What is the present value here? The present value is this principal outstanding, right? So every time there is a present value calculation, there is a principal outstanding number that will come in. Future value is going to be 0 because there is no final payment that is going to happen. The type means that the payment is happening at the end of the period. In this particular case, if I put 0, that means the payment happens at the end of the period. That's the assumption that we have. If I press OK, I get a negative number here, right? Now, why is a negative number a problem? I need a positive number. It is a negative number because it assumes the direction of payment opposite as the principal. I have taken the loan and I'm paying the EMI, right? So the EMI number gets fixed based on that. We can fix up the EMI number as this. Now, let's say we want the EMI number to be positive. What will I do? In the function arguments, the present value has to be made negative, and you will see the EMI number will become positive. Can I know what is the interest repayment? Interest repayment is 40,000 multiplied by 1%, and I will freeze this 1%. So that's the interest repayment, which means the difference of the EMI minus the interest repayment should be my principal repayment, correct? That gives me the principal repayment for the first month. What does that do to principal outstanding after the second month? 40 lakhs minus 4,000, right? In this particular case, we have to freeze certain line items. So we have to freeze the rate, we have to freeze the tenure. Minus B12 is not going to be frozen because that is the new principal we want, right? So we will freeze the rate, we will freeze the tenure and press enter. Now I will drag it downwards. So In fact, if we do this, this is going to create a small bit of an error here, is because now it assumes this is the loan amount and there are 240 periods outstanding. So we don't necessarily need to do this. Why? It's because we know that the EMI is going to be constant. So that's my EMI. I know this number is constant, right? Now what do we do is we start incorporating what is going to be the interest payment. Interest payment is 1% of 39.95.95.7. Principal repayment is this number. And now I will put the formula here as well so that it becomes 1 plus this. I can now take the selection and drag it downwards till the 240th month. So you see, till here 56 months have gone by and we have the same EMI going through. We keep going down till month number 240 and we are till 228 months, and we go down further, so that's 237 and 38, 39 and 40, right? Now you note that at the end of the period you have about 43,607 outstanding, out of which, after which this final payment gets done. And if you were to extend this calculation for one more month, these three line items for one more month, you will note that you had an outstanding principal of 43,000 in the last month. You paid that principal and you paid the 1 month interest on that principal as well, which kept the equated installment equal, right? So the installment is 44,043, and that is how you keep on repaying the entire schedule over a period of the loan tenure, right? So let's just for understanding sake do this once again. I will select this entire set, delete it. Let's put in the data in EMI once. So what is the EMI? That's the PMT function. We need to put in the rate, which is 1%, and freeze it. We need to put in the number of periods, that's 240. We need to put in the present value and a negative of the present value so that we get a positive outside. If you leave type blank, it will give you a 0. That gives you the EMI. Now principal outstanding is the first month principal minus the principal repayment. Interest payment is a direct calculation. This number is equal to the final number because EMIs are going to be constant. That's the calculation, and we can now double click this here so that the entire calculation gets done and we have the entire set of the EMI schedule creation, right? Now PMT is the function that gives EMI payment. There is interestingly another function that can give you the principal repayment as well. Here we calculated it based on EMI minus the interest. Let's say you don't want to calculate the interest repayment. You can use a function called as PPMT. That's principal payment, right? Payment is PMT, which is EMI payment. PPMT is principal payment. So let's actually just try and plug that number in here, right? So what I'm going to do is PPMT bracket open. Let's look at the function arguments. We have the rate, which is 1%. I have to freeze this. Now there is another argument called period. This is what is the period in which the payment is happening. The function needs to know whether it is the first month, the second month, the third month, the fourth month, where, right? This period is going to be the month in which you are going to make the payment, correct? Once you link this period, what is the number of periods? That's frozen to 240. What is the present value in this case? Now remember, the present value in this case will also keep changing because that's the principal outstanding at the beginning of the month, correct? So that's the present value. There is no future value. That's going to be 0. We can leave it blank. And when you close the bracket, you find that the EMI calculated, the principal calculated is the same as what we saw here. This cell and this cell give you the same principal calculation, correct? So that's the PPMT calculation. Let's do it for the next month. There's a small thing that we have done. We should be freezing the principal outstanding as well. in the present value terms. So you have to freeze this as well, because that's known to us at the beginning, that this is going to be 40 lakhs and that 40 lakhs has to be repaid. Once we have frozen this, let's see what happens if we drag this downwards. We get 4084. Let's see what happens if we drag this further, 4125, 4166, which is the same as what we get here. Now you could actually, instead of calculating what is going to be the principal repayment using the formula, you could calculate principal repayment using this and then back calculate the interest repayment. You don't necessarily need to calculate the interest payment using this 1%. So either way is fine. You can calculate the EMI regardless of what's the component of interest and principal based on the principal outstanding. And then you can calculate interest repayment and finally get to the principal repayment using what we did here. Or you could calculate the EMI and the principal repayment using the function PPMT and then back calculate the interest repayment from that function. Either of these two methods is fine. You will note that if I keep taking this further down, it will exactly match the number of the principal repayment every month. That's how you create a loan schedule for EMI calculations and repayment of home loans, education loans, etc. It's going to be exactly the same. You have to convert the tenure into months because this is an EMI equated monthly installment. The interest rate becomes monthly as well, so you have to convert that from 12% to 1%, and then rest of it is a calculation of the PMT function and PPMT function.